Hey guys, in this video you will learn about the MQTT protocol. We will use MQTT protocol to enable cloud communication and the remote control of the IoT devices. Towards the end of this video, you will also learn to configure your Kreator device with the required MQTT configuration. So let's get started. MQTT stands for Messaging Queue Telemetry Transport, and this protocol is based on publish and subscribe mechanism. It is an open source protocol meant for machine-to-machine communication, and it was designed for networks with low bandwidth and high latency. MQTT is a lightweight protocol very well suited for resource-constrained devices like microcontrollers, etc. In our case, we will use it on our IoT devices as our remote communication protocol. This protocol supports secure bidirectional communication and is 100 times faster than HTTP. In a simplistic MQTT communication scenario, there are a minimum of 3 parties involved. The first one is a server, which is also known as a broker in the MQTT context, and the remaining 2 parties are the 2 clients which are trying to communicate to each other. The MQTT protocol supports one-to-many communication. Multiple clients can receive the content sent by another client connected to the same broker. The broker or the server used in MQTT communication does not store any content and is just responsible for passing on the content between the different clients. The content that is being passed is often referred to as payload. The content transfer between 2 or multiple clients is based on a simple string known as topic. A topic is just a string that specifies the interest of a client in a particular content or the content type. Any client interested in receiving information of a particular interest subscribes to a particular topic and is known as a subscriber. And the client willing to send the data publishes it to the same topic and is known as the publisher. Each topic must contain at least one character and can include spaces. The topics are case sensitive, which means the same topic in lowercase letter is not same as the same topic in uppercase letter and will be considered as 2 different topics. All the clients can play the role of a subscriber and a publisher as needed, and they can simultaneously be a subscriber and publisher of several different topics. The MQTT protocol supports 3 levels of quality of service, and we choose one of these based on how important it is for the messages to be delivered to the other clients. The first level of quality of service is level 0. Which is basically fire and forget. In this mode, there is no guarantee of message delivery. If the connection is lost, the messages are lost too. The second level of quality of service is level 1. In this case, the broker tries to publish a message to the clients at least once. The messages are temporarily stored on the server and can survive connection lost. However, the messages being delivered to the client might be duplicate. The third level of quality of service is level 2, in which the broker tries to publish a message exactly once. Messages are stored on the server and can survive connection loss. However, the broker ensures that the messages being delivered to the clients are not duplicated. Now, the last thing that we need to understand is when to use the MQTT protocol. This protocol is suitable for high-frequency data exchange applications, and it is well suited to be used in IoT communication scenarios where majority of times the IoT devices are meant to send real-time sensor data to the cloud. Any other protocol like HTTP, which has an overhead of connection and disconnection, cannot be used in such cases. However, MQTT protocol is not suited for transferring large binary data files like images, PDFs, etc. and is commonly used for plain text communication and for sending across small payloads with sensor information and other relevant data. So guys, now let me give you a demonstration of how MQTT works. For this, the application that we will use is MQTTBox, which is basically a MQTT client. We will also use a web-based MQTT client application to show you how the communication works between multiple clients. If you have not installed the application, you can do so by going to your browser and installing it from the Microsoft App Store. Let me show you how you can do that. Search here for MQTTBox Windows. You'll get the first link which will allow you to install the MQTTBox application from the Microsoft App Store. You can click on download and you can install it on your machine. In the next step, we will launch the MQTTBox application. We will launch another instance of the same application to simulate a second MQTT client. These clients will simulate 2 different IoT devices. Once you are on this screen, click on Create MQTT Client to create a new MQTT client connection. For our demonstration, we will be using the broker as broker.hivemq.com, which is a freely available public broker. Type the broker name over here. The default port number of broker.hivemq.com is 1883. The protocol that we want to select here is the MQTT/TCP protocol, and give this MQTT client name as IoT device 1. Now what we'll do is we'll go to the second instance of the MQTTBox application. We will create a client here also, and we can call it IoT device 2, and the rest of the setting stays the same. Now this instance of the MQTT broker application will behave like the second client. The next thing that we want to do is to launch the web-based MQTT client. The URL is given in the description. Once you're on this page, click on new connection. Let's call this connection as IoT device 3. Since this is a web client, the protocol will be WS, which stands for WebSocket. And we will connect to the same broker, which was broker.hivemq.com. The port number will be 1883 and the path will be /MQTT. We are not going to change this path for now. Let's click on connect and see if it connects to the broker. Once we click on connect, I believe we have the wrong port over here. The port number for WebSocket client of broker.hivemq.com is 8000. Let's try and connect now. You can see it just got connected. So now what you see in front of you are basically 3 instances of the MQTT client. This one behaves as the first IoT device. This one behaves as the second IoT device. And the one which is web-based will behave as IoT device 3. Now let's try out and understand the concept of subscribing and publishing. So the concept of subscription is that the IoT device is willing to receive some data. For this purpose, what we'll do is we'll give a string topic over here. Since the IoT device is willing to receive data, we will call it incoming data. The topic in our case will be incoming / I will call ID, which is IoT device 3. This is IoT device 1. So we will call it IoT device 1 and we will subscribe to this topic. We'll copy this. Now what we'll do is we'll go to the second client. Now let's say this client wants to send some data to IoT device 1. What it will do is it will try to publish to the same channel, which was incoming / ID1, and if I write a message saying payload from IoT device 2, this payload will be received by IoT device 1. So this is how a very basic publishing and subscription mechanism works in the MQTT world. At the same time, if the IoT device 1 wants to send some data to IoT device 2, so this IoT device has to subscribe to an incoming topic with a unique ID called incoming / ID2. The name of this device is IoT device 2, so we call it ID2 and we'll subscribe to this. Now for this device, which is IoT device 1, if it wants to publish any data to IoT device 2, all it has to do is use the correct topic and say payload data from, or you can say temperature data from IoT device 1. You can see that the data has been published by IoT device 1 and the second IoT device was able to receive it. Now let's see the third scenario where there is one device which is trying to send data to multiple devices. Now let's say there is some specific data, like one of the devices has got the temperature data and the device wants to publish that data to multiple IoT clients. Since the first IoT device is trying to publish data which should be received by all the IoT client, the topic will be a little more generic. So the topic has to be an outgoing topic. So we will call it outgoing / the value or the parameter that the device is trying to send. So in our case, it is going to be temperature. Now both the devices has to subscribe to the same outgoing topic, which is outgoing temp. I'll subscribe to outgoing temp in device 2, and we will also create a new subscription on the web client with outgoing temp as the topic. So once we publish any data from this particular MQTT client, it will be received by both the MQTT clients which are working in subscription mode. So let me just type some message saying temperature : 24 degrees C. So if I publish this, you can see that the web client has received the same information and even the second device has received the same information about the temperature. So this was a very basic demonstration of configuring the MQTT clients and the mechanism of subscribing and publishing to various topics, and how you can facilitate data communication between various clients. So in the next step, we will learn how we can configure our Kreator device so that it can connect to the MQTT broker and start receiving and sending data to the different MQTT clients. Now, to perform the MQTT configuration of your Kreator device, you have to launch your Postman application. This is the same application we have used earlier for configuring our device with the SSID and the Wi-Fi credentials. Now, this is how the MQTT configuration API looks like. The type of the request has to be POST. The URL of the API is http:// and the IP address of your Kreator device /endpoint/MQTT configuration. Now, it is very important to understand that the IP address over here should be the IP address of your Kreator device. Now, there are two ways you can get hold of this IP address. The first way is you launch your PuTTY application and connect to your ESP32 device over USB. Now, once your connection is successful, you can get hold of the IP address over here, and you have to use the same IP address in your URL. Now, these are the parameters that we have to send to the Kreator device. The first one is the URL, which is broker.hivemq.com. The second one is the default port, which is 1883. Since this is a demonstration, we don't want to enable it with security. So TLS would be disabled and the value will be 0. Enabled flag is kept as 1, which means your MQTT connectivity is enabled. The next two parameters, username and password, can be kept empty. The topic path is something which is not very useful right now. Either you can leave it empty or you can provide some value in your case. And then you can click on send. Once you do this, you can see your MQTT connection has been successful. The next thing that you might want to take a note of are these two strings, the incoming MQTT topic and the outgoing MQTT topic. And we'll just note it down on a notepad. Post that, we can close the PuTTY application. And we can also close the Postman application. Now, to verify if our connection was successful, we'll open the MQTTBox application. I already have created an IoT dashboard client, which is connecting to the same broker over the same port. The protocol also remains the same. Now, to be able to receive any data which is being published by the Kreator device, what we have to do is we have to subscribe to the topic which is the outgoing topic for our device. Now, if you see here, the outgoing MQTT topic for our devices from device with a particular ID / the path that we have mentioned over there. We will copy this and we will put it here and then click on subscribe. Right now, all you can see is the name and the heap memory of the device is being published, because there is no other feature that has been enabled on this device so far. Just for the sake of demo, I'm going to go back to Postman and enable the temperature sensor and the temperature port on the device, and then you can see that the temperature values are also being published to this particular dashboard. This is another API that I'm going to hit to enable the temperature sensor. Now, once we have enabled the temperature port on our device and we already have a temperature sensor connected to the device, you can see that we have started to receive the temperature and the humidity information on the IoT dashboard client. In our next video, we will see how you can connect various sensors to the device and how you can enable those sensors so that you can start getting hold of this data on your dashboards. Thank you for watching and stay tuned for my next video.